Okay, here's page 2 from the homework. And on page 2, there's a big table with 5 rows, 5 different reactions. It's asking a few things here. It's asking to write the K expression and calculate the value for K for each of the given concentrations. It says based on the data in the data table, put a star next to the reaction which contains the largest amount of products, and then put 2 stars next to the reaction which contains the largest amount of reactants. So we're going to look at the value for K, because remember, K is products over reactants. So if it has the most products, it's going to have the largest numerator, and if it has the most reactants, it will have the largest denominator. The largest denominator, if you have a large denominator in a fraction, it's going to be the smallest number. So if you look at each of these, and there were a few mathematical errors and that I noticed, so I'm going to go through a couple of these. And then also says something of circling the number of the reaction. That's from a different, I just never took that out. I took a column out of this worksheet, so I apologize there. So if you look at this first problem here, 2CH4 in equilibrium with C2H2 plus 3H2, here's the K. C2H2 the first times H2 cubed over CH4 squared. There's your K expression. And then you're going to plug the values in. Here are the values right here. C2H2 is 0.194. H2 is 0.582 cubed over CH4, which is 0.5 squared. So now, one thing I notice here is it says 0.194 times 0.582. Now, if you don't have a scientific calculator, you could just multiply 0.582 3 times, because that's what it means to cube something, multiplying by itself 3 times. So this whole numerator is 0.0382. Now, you don't want to round too much, because if you round too much, especially with small numbers, you're going to get a little bit of a different answer than what my answer key is. Divided by 0.5 squared. 0.5 squared is 0.25. So if you divide 0.032 divided by 0.25, you get 0.153. So again, if you're not agreeing with the numbers that I get, work it out. Find the numerator, find the denominator, and then divide them together. Next one, a little bit easier because there's no exponents involved, because everything is 1:1:1 mole ratio. So you write your K expression, products over reactants, NH3 times CO over HCO NH2. It's all balanced. And now you're just going to plug the numbers in. NH3 and CO are both 0.3. 0.3 times 0.3 over 0.019. Just to give you this numerator here is 0.09. And the denominator is still 0.019. So if you divide those two, you see the numerator is larger than the denominator, so the K is a little bit bigger than 1, 4.74. Moving down to the third one, PCl5 is in equilibrium with PCl3 plus Cl2. Again, it's all 1:1 mole ratio, so there are no exponents. It's just products over reactants multiplying the concentration of the products. PCl3 is 0.45, Cl2 is 0.22, PCl5 is 0.3. So if I were to expand this out, 0.45 times 0.22 is 0.099 divided by 0.3. Now you notice the numerator is now smaller than the denominator. When we divide these two things together, we get 0.33, a K less than 1. If there's a K less than 1, that means there's more reactants present at equilibrium. If the K is greater than 1, that means there's more products. We'll look at row 4, N2O4 in equilibrium with 2NO2. The K expression is NO2 squared over N2O4 to the first power. Plugging these numbers into the K expression, NO2 is 0.056. 0.056 squared is 0.003136. Now notice I'm not rounding. This is exactly what the calculator gave me. I'm not rounding anything. Some of you are rounding, would have called this just 0.003. When you're dealing with small numbers, that's a big difference. We're going to divide that by the denominator, 0.754. Divided by 0.754, and we get this number 4.16 times 10 to the negative third, or 0.00416. Notice this is a very small number. That means there's a lot more reactants than there are products. And then finally, number 5 is H2 plus I2 gives us 2HI. The K expression is HI squared over H2 times I2, both to the first power. Here are the concentrations. HI is 0.78, so 0.78 squared. Pop that in the calculator. 0.78 squared is 0.6084 divided by the denominator, which is H2 times I2, 0.5 times 0.11, both to the first power, and that's 0.055. So you notice the denominator is larger than the numerator is larger than the denominator. Divide those through, and we get 11.1. So that's what we need to do to find K. Now, for the second part, where it's saying which is the one that has the most reactants, we're looking for the smallest value for K. And that's the fourth one, 0.00448 or 0.416. That's why there's 2 stars here. The one that's the largest amount of products, I need to apologize. There's a typo here. When I answered this, I didn't notice that there was a decimal point in front of 0.153, but the largest K value is the fifth, 11.1. So that's 1 star. That's the highest amount of products compared to reactants. I hope this helped. If you have any questions, please come and see me through Google Meet.